This right here is just some fun stuff that I just decided to put together. I got the Raspberry Pi connected to the ribbon cable, and the ribbon cable connected to a breadboard, and you can see there's all these different specifications we could use. All the GPIO with a number after it is the inputs or outputs, and GNDs for grounds, and the rest doesn't matter. It's just the GPIO numbers we're using. All these lights represent outputs. Each one's connected to a resistor to limit the current so they don't blow out the cores, and they're connected to these inputs right here. This takes care of the segments. If I turn it, you can see it change. And this takes care of the contrast. Or the backlight. Yes, this is the backlight, and here's the contrast. And then all these are connected to this side of the board for inputs and outputs. And they're all being programmed right here on the screen. And I'll just, this is the top, so we're importing some important libraries so we can use them. I'm using the BCM mode for the inputs. So in other words, I'm using the numbers that are associated with the board, and not an order sequence, which is 1, 2, 3, 4, 5, 6, all the way from 1 to the 1 on the left, 1 on 2 on the right, 3 on the left, 4 on the right, back and forth. We're setting up the number 23 as an input, and the rest of these as outputs. These are all the lights, and we're not using the input right now, so it's kind of redundant to have it there. And I'm setting the outputs all to 0 so that when we start it, some of the lights are actually turned on. Some of these outputs have a high value, and this right here, we're defining what the inputs are going to be for what the LCD numbers associated with, and we're setting up the backlight to a value of 4, and the columns of 16 and the rows of 2. And then this right here is the key part. It's creating, get that glare out of the way. This here is creating the function from the library LCD and Adafruit, and we're naming it LCD. So we could do LCD.clear, which clears all the segments here, and here we have a function defined with a parameter named num, and so num's got to be defined somewhere in here or used. And we are using it, but what it's doing is it's taking the number, because we're passing in this parameter. There's a number being passed in for num when we call in test, and that number is going to be displayed as an output. And then you can see that here. It's LCD message. We're turning it into a string because we have the word on there, so that's a string. We gotta have it. The number is a string too. And we sleep for a second. We clear the screen, and then we do the output off, and do the same thing. And at the end, active is false. So what does that mean? It's a Boolean expression. So that means that it comes back up here because we're in a while loop. And while active's true, it'll continue to do this, but it's false. So it's actually gonna break out of this loop. But where did we call test at? Well, here we have this function called start, and while true means it's always going to be true, so it's always going to go through this. But right here's where we start. Actually, start is we call in the function, and so we jump to this function first after everything goes through, and while true, num equals 22. So we're calling test right here and passing the word num, and num is equal to 22 here, so we're passing this word num into test. We can name this anything we want here, but we have to keep it consistent within this function. So that 22 gets passed into num right there at test, and then it goes through the sequence. But when it jumps out, it goes all the way back down, goes to start again. Or I'm sorry, no, it stays in this function. It jumps, once it's done, it goes right back here to test and goes to num equals 5 and then jumps to test again. So we're changing the value of num. And I just thought everybody would like to see that. It's pretty simple to do. I plan on creating a vending machine, but it's going to be difficult because of the money input.